In this video, we're going to explore this tutorial which contains animations of the behavior of C++ standard library containers and algorithms. So our first example is called element access, and in this specific tutorial we have the code that demonstrates the use of a vector of integers. So to begin with, supposedly we enter this function void f, and it starts to execute. So the first line of code here creates a vector of 5 elements populated specifically with the value 0. In next loop we are using container element access. Of course, elements are numbered here 0, 1, 2, 3, 4. They're all 0 based. By using square bracket notation or subscript operator notation, by using the index variable I and referring to the name of this vector v, and basically updating in this loop in range from 0 to its size minus 1, which is actually 4, from 0 to 4, we're updating. You can see that we just made this update using this simple formula 10 plus I, updated all of the elements with new values. So this demonstrates the access to the vector using square brackets. The square brackets, you have to be careful with an index, because if you provide an index which is out of range, which is outside of the size of this container, then you should expect memory access violation exception or error at runtime, and basically the behavior of your application will be unpredictable. So this is totally unchecked way of accessing individual elements, and you have to be careful. At the same time, it should be easy enough for you to recognize that the vector provides its size member function, which of course will tell you how big the vector is. So here it's perfectly safe to organize a loop like this and make this update. The vector also comes with front and back, and you can see that as I'm making progress through this demonstration, both front and back were set to new value 1. So the old values are being reassigned, and front simply provides access to the initial value. It's the same as v with index 0, and the back function of course provides access to the last element. Now if a container would be empty, then using these front and back functions of vector would be resulting again in a memory access violation, and once again the behavior of the vector would become unpredictable. So you have to be careful to make sure that you still have some elements populated inside the vector. If vector size is 1, so if the vector is of size 1, then front and back refer to the same element. And in the next if statement right here, what we do is that we compare 0 and 4, right? So we just compared element 0 and element 4. If they are equal, we set v1 to specific value, which is 555. Now the at member function of vector provides checked access, range checked access to vector elements. So it should be used in situations where you could generate a runtime exception thrown by vector itself. So you have a chance to catch that exception and proceed accordingly. So basically, it's a safer version of the use of square brackets. Of course, I would like also to say that the second name for vector in C++ standard library is dynamic array. And we say dynamic array because of course vector populates all of its elements dynamically. And by the way, if we click on the closing brace, you see that the vector gets deallocated and returns back all allocated memory to the system. And so once again we call it dynamic array because it sort of imitates as much as possible the behavior of primitive C++ array, which also permits us to use square bracket notation to access its elements.